This video will focus on solving rational equations. When we solve rational equations, you're essentially going to have two fractions, one on each side of the equation. And when we have this, we can solve by using cross multiplication. Right by where it says example 1, notice it says, and this is very important, so maybe you want to star it or highlight it, cross multiplying only works if there is one fraction on each side of the equation. So let's say if I were adding or subtracting something here, I'd have to add or subtract first before I could use cross multiplication. And after we cross multiply, we're going to state any extraneous solutions. Remember, extraneous means false solution or an extra solution, something that doesn't really work. And we can predict what x can't be by seeing when the original factored denominator equals 0. We've done that earlier in this chapter. Or you could always just plug your solution back into the original equation and see if you get the same thing on each side. So I'm going to leave that up to you. I think it would be easiest just to do the first option, which is predicting when x can't equal some number. Let's just practice our cross multiplication skills. Remember, when you cross multiply, we multiply the diagonals. So 2 times x plus 5, x times 5. I'm just going to rewrite it so we can see how it looks. It's 2 times the entire expression x plus 5. So that 2 is going to end up going to both the x and the 5. And then I have 5 times x on the other side. I'm going to go ahead and distribute the 2 like I was talking about. So it's 2x plus 10 equals 5x. And now you just need to solve for x. This is just basic algebra. I like to always make sure that my x value remains positive, so I'm just going to move my 2x over to this side, leaving me with 10 equals 3x. And then to get x by itself, I need to divide each side by 3. So x equals 10/3. Of course, you always want to check and see if you can simplify any further. 10 over 3 does not, however, so that is my possible solution. I say possible solution because I do need to check and see whether or not this is extraneous. Remember, there's two ways we can check. First is just seeing where it cannot be, and the second is plugging the 10/3 back into the original equation and seeing if you get the same thing on each side. I'm going to do the first method just because some students struggled with that earlier. So I need to say when it's undefined. And we're going to look at the original denominators, both of them. So there's two that I need to take a look at. I'm going to set x equal to 0 because that's my first denominator, and x plus 5 equal to 0. And solve for x. This one is already x equals to 0, so now I just need to solve for x over here. Subtract 5 from each side, you get x equals -5. So x cannot equal 0 or -5. But lucky for us, 10/3 is neither of those numbers. So this is a solution. Let's try part B. Once again, we are going to cross multiply. So 2 times x minus 1 equals 1 times x squared minus x. Or whenever you multiply something by 1, you just get itself. And over here, I'm going to have to distribute the 2, leaving me with 2x minus 2 equals x squared minus x. Now this is interesting because when we're solving for x, I now have a quadratic equation. So it's not as easy as what we did for part A. With quadratic equations, you want to get them set equal to 0 first. And you usually want your first term to be positive. So I'm going to try and make sure that this x squared stays positive, meaning I'm going to have to move my left side over to the right side. I do this using inverse operations. So 0 equals x squared. Combine your like terms. Negative x minus 2x is a negative 3x, and then I just had a plus 2. When we solve quadratic functions, remember, you could factor, you could use the quadratic formula, you could graph, you could complete the square. There's a whole bunch of different options that you learned. I say let's try to keep factoring if we can. So when I take a look here, I have 0 equals, this is a case 1 trinomial. I know that because it has 3 terms and the leading coefficient is 1, which means I can use guess and check. The factors of 2 are 1 and 2. Using same signs, I can get to a negative 3. I just have to put minus minus. So it's x minus 1 times x minus 2. That means that there's 2 possible solutions. We would get each by setting the parentheses equal to 0. So x minus 1 equal to 0 would give me a positive 1, and x minus 2 equal to 0 would give me a positive 2. Now I need to check these solutions to make sure they both work, or just one of them works, or none of them works. And I do that by looking at the original factored denominators. So for my, I'll just write it here, first denominator, I have x squared minus x equals 0. So if I'm looking at that, that's kind of hard to tell what the solution is. So we're going to have to factor it by pulling out a GCF of x. Now I can see that I have to set x equal to 0 and x minus 1 equal to 0, which gives me x and 1. The second denominator was x minus 1, set that equal to 0, which once again gives us a solution of 1. So x cannot equal 0 or 1. If you take a look at our original solutions, 1 was listed, so this would be extraneous. It's a false solution. But 2 is neither of these numbers. So we do have one solution of 2. Part C. Once again, we're going to cross multiply. So I get 3x times x minus 3 equals x minus 3 times 2x plus 3. Now, I need to clean this up so I can see what's going on, and we're trying to solve for x. Over here I would have to distribute, giving me 3x squared minus 9x. And then over here I'm going to have to FOIL it out. I know that because I have 2 binomials being multiplied together. X times 2x is 2x squared. X times 3 is a positive 3x. Negative 3 times 2x is a negative 6x. Negative 3 times positive 3 is a negative 9. Okay? Remember, I had said in example B that when we have a quadratic, so I can tell that because I have an x squared, we want to get it set equal to 0. And I want to do this making sure that my x squared term is positive. If I were to move this 3x squared over here, I would get a negative. So I don't want to do that. Instead, I'm going to move my 2x over here by subtracting. Which means I'm going to have to move all this other stuff over to the left-hand side. Now, you can go ahead and combine these terms as well. This is a negative 3x, so I need to add 3x to each side in order to cancel them out. and then I need to add a 9. This leaves me with x squared minus 6x plus 9 equals 0. Now that I have a quadratic set equal to 0, we're going to try and factor. This, once again, is a case 1 trinomial. The factors of 9 are 1 and 9, 3 and 3. Using same signs, I could get to a negative 6 if I use negative 3's. So x minus 3, x minus 3. Set both of these equal to 0, but since they're the same thing, really, I just have one possible solution of a positive 3. Now, we do need to check and see where it's undefined. And we do that by looking at the original denominators. Now, both of them are x minus 3. So the only function, or the only value that would make the function undefined, is 3, which is the solution we got. So I know that this is extraneous. Now, we just said that our only possible solution is extraneous. So that means there really is no solution. For example 1, you saw that all of the examples where we cross-multiplied had one fraction on each side. If I give you something like example 2, where there's multiple fractions, we're not going to use cross-multiplication. It only works when there's one fraction on each side. When we have something like this, we are going to have to multiply each term by the least common denominator. And that actually will make everything whole numbers, so you don't have to deal with fractions at all, which is awesome for those of you who struggle with fractions. So I'm going to go through example A to A just to show you what I mean. The first thing I need to do is identify the least common denominator. Remember, least common denominator, we factor if we can, then we identify similarities and differences and multiply them together. So a similarity is something that we see more than once, which I see x more than once. I only want to account for that one time. I don't want to repeat it. And then a difference is something we only see once, which is 2. Now I need to multiply each term by that 2x. So I have 2x times the 4 over x plus 2x times the 5 halves equals 2x times the negative 11 over x. Whoops. Now when I do this, notice what happens in the first term. I have an x in the numerator and the denominator, so they cancel, leaving me with 4 times 2, which is 8, plus I have a 2 in the numerator and denominator, so those cancel, and I'm left with 5 times x. And in the last term, I have an x in the numerator and denominator, so those cancel, and I have 2 times negative 11, or negative 22. And I just solve for x. So I'm going to subtract 8 from each side, leaving me with 5x equals negative 30. And then divide by 5 on each side to get the x by itself. So x equals negative 6. This is only a possible solution. So once again, we have to check and see if it's extraneous. And we do that by looking at our original denominators once again. So when the original denominators equal 0. X equals 0, well, that just gives me the solution of 0, right? So x cannot equal 0. 2 equals 0. 2 will never equal 0, so I don't get an extraneous solution from that. And then x equals 0, we already did that. So is negative 6 a solution? Yes, because it is not the value that would make the function undefined.